October 16, 1941, 3:47 a.m. Kharkiv, Ukraine. While most of the city sleeps, engineers at the Kharkiv tank factory are doing something that should be impossible. They're dismantling a 15-ton hydraulic press, a machine that takes 6 months to install, in complete darkness. They have 4 hours before German reconnaissance planes arrive at dawn. But here is what makes this truly insane. They're not just moving equipment, they're relocating an entire industrial ecosystem. Blast furnaces still warm from yesterday's production, assembly lines midway through building tanks, even the workers' families onto trains heading east into the Ural Mountains. In winter, through partisan-controlled territory, while being bombed. The Soviet Union is about to attempt the largest industrial migration in human history, and if they fail, Nazi Germany wins the war. Today, we're diving into one of the most extraordinary engineering operations ever executed under combat conditions. How Soviet engineers moved 1,523 factories over 1,000 miles, rebuilt them in 8 weeks in the middle of Siberian winter, and kept producing the tanks that would eventually crush the Wehrmacht. This isn't a story about battles. This is about the logistical miracle that made victory possible.
Let's establish exactly how desperate things were in the autumn of 1941. Operation Barbarossa, Germany's invasion of the Soviet Union, had launched on June 22, 1941. Within 5 months, Nazi forces had captured territories containing 40% of the Soviet population and, more critically, 60% of their industrial capacity. The Kharkiv tank factory we just mentioned? It produced the T-34 medium tank, the best tank in the world at that moment. The Germans knew this. That's why 3 panzer divisions were racing toward Kharkiv with one objective: destroy that factory before the Soviets could relocate it. But Kharkiv wasn't alone. The Soviets had major industrial centers in Leningrad, Moscow, Kiev, and throughout Ukraine, the industrial heartland of the USSR. All of these cities were either under siege, under bombardment, or about to fall. Here's the nightmare scenario facing Soviet planners in October 1941. Their western industrial base was collapsing. The Kirov plant in Leningrad, which produced heavy KV-1 tanks, was surrounded. The ZIS truck factory in Moscow was 30 miles from German forward positions. The aircraft factories in Kiev had already fallen. Production of tanks, aircraft, artillery, trucks, ammunition, everything was plummeting exactly when they needed it most. The Red Army was losing approximately 20,000 soldiers per day. They were burning through tanks faster than they could build them. And winter was coming, the infamous Russian winter that everyone assumes would automatically help the Soviets. But winter was actually their enemy in this situation. Why? Because moving a factory in winter means working in temperatures of -30 to -40 degrees Celsius, frozen rail lines that crack and break, locomotives that refuse to start, workers who freeze to death during the journey, machinery that shatters when exposed to extreme cold, and most critically, trying to pour concrete foundations and construct factory buildings when the ground is frozen solid as granite. But they didn't know that Soviet engineers had been planning for exactly this scenario.
The Soviet evacuation wasn't improvised chaos. It was calculated chaos. In July 1941, just 3 weeks after the invasion began, the Soviet government established the Council for Evacuation, chaired by Nikolai Zvernik. This council had one job: create a systematic process for moving entire factories eastward before the Germans could capture or destroy them. Their plan was audacious: identify which factories were critical to war production, prioritize tank, aircraft, ammunition, and weapons facilities, create detailed inventories of every machine down to individual drill presses, assign rail capacity for each factory based on production importance,
designate new locations in the Urals, Siberia, and Central Asia, and do all of this while fighting a war. The target destinations were cities most people had never heard of: Chelyabinsk, Sverdlovsk, Magnitogorsk, Nizhny Tagil, Omsk. These weren't industrial centers, they were frontier towns, some barely more than villages. But they had three critical advantages. They were 1,000 to 1,500 miles behind the front lines, beyond the range of German bombers. They had rail connections to the Trans-Siberian Railway, and they had space, vast empty space where new factory complexes could be built. The Kharkiv tank factory was designated to move to Nizhny Tagil, a small city in the Ural Mountains. The Kirov plant in Leningrad would relocate to Chelyabinsk. The Moscow-based factories would scatter across multiple sites. But here's the engineering challenge that makes this extraordinary. You can't just throw machines onto trains and hope for the best. A factory is an integrated system. The sequence of production matters. A stamping press is useless without the dies that shape the metal. A welding station needs specific power requirements. Heat treatment furnaces require precise temperature controls. Assembly lines must be positioned in exact geometric relationships. The engineers had to essentially create 3D blueprints, mapping every machine's position, every power cable, every coolant line, every workflow connection. Then they had to pack it all so it could survive a 1,000-mile journey on rail lines that were being bombed, and then rebuild it all in the correct sequence. Think about moving your kitchen. Now imagine moving 500 kitchens that all have to work together perfectly in the middle of a blizzard while someone is shooting at you. The real breakthrough came when they realized they couldn't move factories like static objects. They had to move them like living organisms.
The trains departing Kharkov weren't heading into safety. They were heading into chaos. The Soviet rail network in late 1941 was a nightmare of conflicting priorities. You had trains moving factories east, trains moving military units west to the front, trains evacuating civilians, trains bringing supplies forward, all competing for the same rail lines. The entire Soviet Union essentially had four major rail corridors heading east. The primary route from Ukraine to the Urals was approximately 1,200 miles, normally a 4 to 5 day journey. In the autumn of 1941, that same journey took 3 to 4 weeks. Why? First, German bombing. The Luftwaffe specifically targeted rail junctions, bridges, and marshalling yards. Every day, somewhere along the route, tracks were destroyed. Trains had to halt, sometimes for days, while repair crews fixed the damage. Second, bottlenecks. The Volga River crossings became catastrophic choke points. There were only a handful of rail bridges and thousands of trains trying to cross. Trains would queue for a week, just waiting for their turn. Third, the cold. When temperatures dropped below -30 Celsius, locomotives literally froze solid. The coal wouldn't ignite properly. Lubricants turned to sludge. Water in the boilers froze. Engineers had to keep fires burning continuously underneath locomotives just to keep them operational. But here's what made this different from a normal evacuation. The factories couldn't just be transported, they had to be protected in transit. Sensitive machinery, precision measuring equipment, optical devices, specialized cutting tools had to maintain their calibration. A lathe accurate to 0.01 millimeters doesn't remain accurate after being bounced around in a freight car for 3 weeks in sub-zero temperatures. The solution? Keep the factories alive during transport. Engineers traveled with their equipment, not as passengers, but as caretakers. They rode in unheated freight cars for weeks, maintaining their machines. They wrapped sensitive equipment in layers of blankets. They burned small fires inside cars to keep temperatures above critical thresholds. They manually shifted loads when trains bounced to prevent tipping. Some trains became mobile workshops.
If something broke during the journey, a crane, a hoist, a transport frame, they repaired it on the spot using tools and materials from the very factory they were transporting. The human cost was brutal. Workers froze to death in unheated freight cars. Families huddled together for warmth. Food was scarce, often just bread and whatever could be scavenged at stations. Disease spread in the cramped conditions. One account from the Ural plant evacuation describes workers discovering that 3 families had frozen to death in a freight car that had been detached at a siding and forgotten for 5 days. But the trains kept moving. By December 1941, over 1,523 factories, including 1,360 major industrial plants, had been relocated eastward. That's approximately 10 million tons of equipment, transported on over 1.5 million railcar journeys. The Kharkiv tank factory's equipment arrived in Nizhny Tagil in late November 1941. They had survived the journey. But this was only the beginning. Now they had to build in the middle of winter.
October 1941. The disassembly phase begins. At the Kharkiv tank factory, Chief Engineer Yakov Wichmann faces an impossible equation. The German army is 40 miles away and advancing at 15 miles per day. That gives him, at most, 3 days before artillery shells start hitting his factory. He needs 6 weeks to properly dismantle everything. So he divides his workforce into 3 shifts working around the clock. But these aren't normal factory shifts. These are combat engineering operations. Shift 1. Disassembly teams. These workers disconnect machines from their foundations, drain coolant systems, remove electrical connections, and prepare equipment for transport. The challenge? Many machines weigh 10 to 50 tons and are bolted to concrete foundations that were never designed to be removed. Shift 2. Packing and loading teams. They crate sensitive equipment, wrap machinery and protective materials, often just canvas and straw because proper packing materials don't exist, and load everything onto rail cars. The average freight car can hold about 20 tons. A single large press might require 3 cars. The factory has 1,200 major machines. Shift 3. Documentation teams. These engineers photograph every installation, measure every connection, record every specification. Because when they rebuild this factory in Siberia, there won't be any instruction manuals. The pressure is psychological warfare. Every day the sound of artillery gets louder. Workers can see smoke on the horizon from burning villages. German reconnaissance planes fly overhead daily, photographing the evacuation progress. And there's a darker calculation happening. What do you take and what do you destroy? The Soviet scorched earth policy, ordered by Stalin himself, mandated that anything which couldn't be evacuated must be destroyed completely so that the Germans gained nothing. This meant Engineer Wichmann had to make horrifying decisions. This machine, too heavy, destroy it. This assembly jig, custom built over 5 years, no time to dismantle, destroy it. This warehouse of spare parts, can't spare the rail cars, destroy it. Workers smashed what they had built. They wept while sledgehammering their own equipment. But they took the critical core, the production dies that stamped tank hulls, the turret assembly fixtures, the specialized cutting tools, the engineering drawings, and most importantly, the expertise in the form of skilled workers and their families. By October 26th, the Kharkiv factory had loaded 10,089 railcars. That's approximately 200,000 tons of equipment. The last train departed on October 28th. The same day, German artillery began shelling the city's outskirts. They had cut the 6-week timeline down to 12 days. However, the biggest challenge was still ahead: the journey itself.
November 30th, 1941. Nizhny Tagil. Temperature, minus 38 degrees Celsius. The trains carrying the Kharkiv tank factory begin arriving. The workers step off onto frozen platforms and see nothing. Not, there's a building under construction. Not, there's a foundation waiting. Nothing. Empty, frozen steppe, snow-covered ground. A few wooden barracks hastily built for shelter. That's it. They have to build an entire tank factory from nothing in temperatures cold enough to freeze exposed skin in minutes, while the German army is destroying Soviet tank units on the front lines at a catastrophic rate. The deadline? 8 weeks to first production. This is where Soviet engineering pragmatism becomes extraordinary. Forget conventional construction, forget building codes, forget comfort or permanence. The only question that matters: can we produce tanks? The construction methodology was brutal in its simplicity. Phase 1. Foundations, sort of. Normal construction requires excavating below the frost line, pouring concrete, waiting for it to cure. That's impossible when the ground is frozen solid and temperatures are minus 40. The solution? Don't excavate. Instead, they cleared snow, built wooden formwork directly on the frozen ground, poured concrete mixed with chemicals that allowed it to set in sub-zero temperatures, and installed machinery before the concrete fully cured. Yes, this meant foundations would crack when spring came. Yes, this meant uneven settling, but it meant production could begin in weeks instead of months. Phase 2. Walls and roofs. Barely. The factory buildings were constructed from whatever materials were available: wood, salvaged metal, canvas tarps, anything. The walls of early production facilities were often just wooden frames with canvas stretched between them. There's a famous photograph from the Tankograd complex in Chelyabinsk showing workers assembling T-34 tanks in a building that had 3 walls and no roof, just canvas tarps overhead, in December, in Siberia. Workers wore every piece of clothing they owned. They worked in shifts, 30 minutes on the production line, 10 minutes warming by fires. Frostbite was universal. Fingers were too numb to hold small tools, so they developed techniques using their palms and forearms. Phase 3. Machine installation. Precision in chaos. This is where the documentation teams proved critical. Despite the chaos, machines had to be installed in precise positions with exact alignments. A tank assembly line isn't flexible. Each station must be positioned so the partially completed tank can move smoothly to the next operation. The engineers used the photographs and measurements taken during disassembly. Working by lamplight in unheated buildings, they recreated the Kharkiv factory's layout. Not perfectly. They made improvements, shortened workflows, eliminated inefficiencies. They were rebuilding and optimizing simultaneously. Power was another nightmare. The local electric grid couldn't support a major industrial facility. Engineers installed temporary generators, created redundant power systems, and prioritized critical machinery. Phase 4. Testing and calibration. Each machine had to be tested after installation. Lathes had to be recalibrated. Presses had to be tested for proper operation. Welding stations required power validation. Heat treatment furnaces needed temperature verification. This normally takes months. They did it in days. The breakthrough was abandoning perfection. A lathe that wobbles slightly? Good enough. Produces tank parts that are 95% as precise. A press that's slower than optimal? Good enough. Still stamps hull plates. A welding station with inconsistent power? Good enough. Weld inspections catch the flaws.
They weren't building precision aircraft engines. They were building tanks designed for short operational lifespans in combat. Good enough was actually good enough. December 27, 1941, 27 days after arrival, the first T-34 tank rolled off the reconstructed assembly line at the Ural Mountains factory in Sverdlovsk. 8 weeks later, the Nizhny Tagil factory, now called Ural Vagon Zavod, reached full production capacity. They were producing 25 T-34 tanks per day. But the real miracle was scale. This wasn't just one factory. This was happening simultaneously at dozens of sites across the Urals in Siberia. The Soviets were creating an entirely new industrial base, building it faster than anyone thought possible under conditions that should have made it impossible. By March 1942, Soviet tank production had not just recovered, it had exceeded pre-war levels. They were producing 2,000 tanks per month from facilities that hadn't existed 4 months earlier. The real breakthrough came when they realized speed mattered more than perfection.
Let's be clear about what this achievement required. The official Soviet statistics record 25 million people were evacuated eastward during 1941-42. At least 30,000 died during the relocations, from cold, disease, starvation, and German attacks. Workers in the new factories lived in conditions that were barely survivable. Housing was primitive, often just holes dug into hillsides covered with tarps. Food rations were minimal, 800 grams of bread per day for workers, less for families. Disease was rampant, typhus, dysentery, pneumonia. But they kept working. Why? Partly desperation. Stalin's regime wasn't known for tolerating failure, but also genuine belief. These workers knew that every tank they produced meant Soviet soldiers had a better chance of survival. Every day of production was a day closer to victory. And they innovated. The relocated factories didn't just recreate what existed, they improved it. Engineers simplified T-34 production, reducing manufacturing time from 8,000 hours per tank to 3,700 hours. They eliminated unnecessary complexity, standardized parts, and optimized workflows. The Tankrograd complex in Chelyabinsk, created by merging the evacuated Kharkiv plant with existing tractor factories, became the largest tank production facility in the world. At peak production, they were completing 1 tank every 13 minutes. The aircraft factories relocated to Siberia developed techniques for cold weather production that had never existed before. They discovered how to work aluminum in sub-zero temperatures, how to paint aircraft when conventional paints froze, how to test engines in extreme cold. These weren't temporary wartime expedients, they were genuine engineering innovations that would influence industrial processes for decades.
Let's connect this to the bigger picture. In 1941, Germany outproduced the Soviet Union in tanks, aircraft, and most weapons. By 1943, the Soviets were outproducing Germany by factors of 3 to 5 times in most categories. The Battle of Kursk in July 1943, the largest tank battle in history, saw the Soviets deploy over 5,000 tanks. Most of those tanks came from factories that hadn't existed 2 years earlier. The relocated factories produced over 100,000 tanks during the war, over 140,000 aircraft, millions of artillery pieces, trucks, and small arms. Without the industrial evacuation, the Soviet Union likely would have collapsed in 1942. Germany would have won the Eastern Front. The entire trajectory of World War II would have changed. But beyond the historical impact, this operation demonstrated principles that remain relevant. Adaptability over perfection. Under extreme pressure, good enough now beats perfect later. Modern manufacturing still struggles with this balance. Documentation enables mobility. Those Soviet engineers who photographed and measured everything made reconstruction possible. Modern knowledge management is the same concept. Decentralization as resilience. Concentrating production in a few locations creates vulnerability. Distributing it creates survival capacity. Human capital matters more than physical capital. The Soviets prioritized evacuating skilled workers over equipment when forced to choose. The expertise rebuilt the factories. The factories didn't rebuild the expertise. And perhaps most importantly, logistics wins wars. The engineers who moved those factories, the rail workers who kept trains running, the construction workers who built in the cold, they never fired a shot, but they won the war as surely as any soldier.
So remember, when you see those grainy photographs of Soviet T-34 tanks rolling through Berlin in 1945, remember that 2 years earlier, those tanks were being assembled in buildings with canvas roofs by workers who were freezing to death. Remember that victory wasn't inevitable. It was engineered. Engineered by people who solved impossible problems under impossible conditions, who moved mountains, literally tons of equipment across mountains, when the alternative was annihilation. The Soviet industrial evacuation of 1941-42 remains the largest logistical operation ever executed under combat conditions. 1,523 factories, 10 million tons of equipment, 25 million people, relocated over 1,000 miles, rebuilt in winter, producing at full capacity in 8 weeks. It shouldn't have been possible, but it was. If this story of engineering triumph under extreme pressure fascinated you, you need to subscribe to this channel. We don't do typical battle narratives. We dive deep into the technical problems that shaped history and the brilliant solutions that changed everything. Hit that subscribe button and turn on notifications, because next week we're exploring another engineering miracle, the story of how Allied engineers built a completely portable artificial harbor in secret, then towed it across the English Channel for D-Day. 2 million tons of concrete, assembled in 12 days, under German artillery fire. Drop a comment below. What's the most impressive engineering achievement you think we should cover? The Burma Railway? The Manhattan Project logistics? The Berlin airlift? Let me know. And if you want to go even deeper into Soviet industrial warfare, check out the video appearing on your screen right now about how the Soviets built a supply road across a frozen lake while under siege, and it actually worked. Thanks for watching, and remember, history's greatest victories weren't won by generals. They were won by engineers solving impossible problems.